Hey everybody, this is Alex Merced and welcome to this next video series on data optimization. So the goal here is just to talk about different ways you can optimize data, particularly for just being able to find what you're looking for quicker when you're not just pulling the whole data set. Hard to optimize pulling the whole data set because you just kind of have to pull every record. But the idea is when you actually run queries and you ask questions, there are ways you can set up your data to give you your answers quicker, especially if you know the types of questions you're going to ask. Now, one method is going to be sorting. Okay, so what I have here is a data set of 100 movies. Okay, 100 TV shows from the 90s. And basically the schema is the name of the TV show, the year that the show premiered, and the number of seasons it had, and the genre. So the question generally you want to first start out is what are the kind of questions I typically are going to ask more often than not? Because it's going to depend on how you want to optimize. And the first optimization we're going to talk about is sorting the data. So in this case, all the data is in one file, or we don't care the number of files that it's stored in. What we care about is how the data is structured in those files. So basically, basically have it in some sort of order, some sort of sort order. So for example, let's say what I generally query is I generally query shows based on genre. So I'm constantly saying, get me all shows of sitcom. Okay. Well, right now, what would it have to do? If we're thinking about a row-based structure, you would have to literally go row by row and like load up the whole row. So we'd have to load up this whole piece of information, determine, oh, that's a sitcom. Okay, good. That gets added to my result list. Then it'd be like, okay, let me load up this row. Well, that's science fiction. That's not going to be part of my result set and has to do that for every row because, well, that's going to take a while. Okay. And basically, a lot is going to not know where to end. Okay, now let's say I sort the data. So I go boop. Okay, so if I sort the data and then I go to, let's see here, been a while. Data sort sheet by column A, sort sheet. Here we go, short range by advanced range sorting options. Okay, I want to do it by column D. And let's just say from A to Z. And we'll say data has a header row, so that way it's nice, good. Okay, so you see here, now, if I had basically do a search, it's much easier for me to find all of them. And even better, if you're talking about like a big data set, which is going to be split up across multiple files, that file split may be, let's say, right here. Okay, so if I insert one row above, okay, so this is going to be file 2. And this will be file 1. Okay, but notice that I'm not segregating the genres. I'm just moving them. File 2. Okay, all I'm doing is I'm just saying within the files, the data that is there is sorted. Okay, but now the beauty of this is that let's say you're using a file format like Apache Iceberg. In the Apache Iceberg metadata, it would know, okay, hey, this file covers action drama to medical drama. This file covers mystery through teen drama. Okay, so then what happens if I say, hey, go get me all sitcoms, okay, using the metadata, it'll know it doesn't have to scan file 1. So it'll just skip file 1. So I've just cut my time in half in scanning the data. Okay. Similarly, with a database or a data warehouse, the only difference is that you don't really see how many constructs your data is contained in. All you know is that your database has the data. Your database is sort of tracking the data under the hood. How it's doing it will differ from database to database, and you don't really know how. You just know that the data is probably going to be stretched across multiple files or multiple things once it becomes larger. But when we're dealing with, again, a Data.Lake data set, we know exactly how many files. We are in control of those files. So in this case, I know there's file 1 and file 2. And based on the Iceberg metadata from Apache Iceberg, we can determine that, hey, we only want to scan file 2 because according to the metadata, that's where all the sitcoms are. There are no sitcoms in file 1. Okay, so that's sorting. Okay, but in order for me to scan all the sitcoms, it's still going to have to go through all the mystery rows, all the science fiction rows, all the supernatural drama rows, all the teen drama rows. Okay, so maybe there might be another option. Another option, which I'm actually going to duplicate from this sheet, okay, is partitioning. So I'm going to delete the sheet that I originally made for partitioning. Okay, is rename partitioning. Now, what's the difference between partitioning and sorting? Sorting just sorts the data. Okay, it doesn't matter how many number of files. So you can actually have action dramas and crime dramas in the same file because it's just sorting. You're just sorting the data so that way the data is in a more logical form, which is going to benefit you in two ways. One, at the iceberg metadata level, it'll be able to determine which files, okay, you don't need. And then at the Parquet file level, let's say the row groups. So let me just go back to the sorting one for a second. Okay, let's say the row groups were like this. Let's say, a row group ended here. Okay, so let's say row group end, and then another one ended up here. Insert row above, row group end. So inside the file, so it's a Parquet file, let's assume it's a Parquet file. Okay, then there's a row group end. So then what'll happen is that basically, let's say I'm scanning all action dramas. Okay, I'm scanning for all action dramas. Actually, let's say all crime dramas. Okay, so what'll happen is at first, the iceberg metadata, if we're, again, assuming an iceberg table, will determine, hey, there is no crime dramas in file 2, so we'll skip file 2. So then we scan file 1, and it's a Parquet file. So then we scan we take a look at the first row group's metadata, so right at the end of the row group, and it says, okay, well, this row has action dramas through crime dramas. So, okay, so there's a crime drama here. So we do want to scan this row group. So then we scan it, grab the sole row group, then we go to the end of the next row group and take a look at its metadata and see, okay, this one has crime dramas and medical dramas. So in that case, we will scan this row group, and, we won't need that one. And then we get to the next row group, we go to the end of that one and say, okay, this is all medical dramas. We're looking for crime dramas. So in that case, we don't need to scan that. So it'll skip that row group. So sorting can optimize not only across multiple files, but in the single file also optimize your ability to scan it, because again, Parquet will break up the single file into different row groups. Again, how will that work in other databases and how they store their data and how they organize that data can be different. But again, Parquet files in an iceberg table, that's something that's very transparent and easy to understand. Okay, so that's sorting. Now in partitioning, what we would do, okay, what we would do is we would just actually choose a field that we want to partition by. So in this case, I'm going to partition by genre, and each of them get a separate file, okay? Or files, depending on how much data there is. So in this case, insert row 1 above. So this is where file 2 is. So basically, if we're partitioning this by crime drama, these are all physically separated. So then you're not going to have anything with different genres in the same file. So all the medical dramas, okay, insert row above, file 3. Okay, this becomes file 4 with the mystery. And then science fiction becomes file 5. And then sitcom becomes file 7. Oh, actually file 6. Okay, and supernatural drama becomes file 7. I think that one more. And teen drama becomes file 8. So now what happens if I am looking for all the sitcoms? It can skip. It'll know the partitioning. So like we're talking about at the iceberg level, iceberg's metadata is going to know which files belong to what partition. So it's going to know that the only file that covers the partitioning of the genre sitcom is going to be file 6. So then it skips everything else. So that's really quick. So right there, you've really sped up your scan, because now you're reading a file that only has the information you need, and we're able to quickly determine that you could skip all the other files. Okay, so this is where the metadata really kind of begins. And then the thing is that you can take that a step further, and I can sort the data within those fields. So I could sit there and say, okay, let's find one that's pretty unsorted. So let's say, okay, over here in file 6, I could further, sort this data. Let's say we sort it by number of seasons. So we'll say sort range, sort by column C. Okay, that's fine with me. Okay. And what do you see? That now, if I were to do a scan of saying, hey, find me a sitcom that has a seasons of 10 or greater. Okay. Now again, if this particular file was broken up into different row groups, so let's insert some row groups here. Basically, it can skip those first 2 row groups and then pull off his data from sitcom 10, because not only are the files partitioned, but then they're also sorted. So you can start seeing like how this can all start really adding up to speeding up the performance of a scan. And that's the beauty of like using Apache Iceberg and its metadata and Parquet files as the underlying store when you're doing analytics. But again, those are a columnar format. So yes, earlier I explained like how it would scan it for a row-based format. So just to kind of explain how it would scan it for a columnar format, if I go back to the original data set, if I were scanning for sitcoms, it would just pull up this column. So instead of loading up each row, it would load up the column and then track the indexes for everywhere sitcom pops up. And then once it tracks up, is able to list sort of like those row numbers, it would then pull out those same row numbers in any other columns that are relevant to my query. So it'll be like, oh, okay, you said you also wanted year premiered, so let me go grab those same row numbers in that column. So again, columnar structure versus row structure, sort of in the way you process the data. But with that, I'll leave it at that. I'll see you guys in the next one. We'll talk about indexing, more specific indexes.